Thank you for your interest in our first ever Mirai webinar. Let's start the first episode called Introduction. In the introduction, we'll cover following topics: brief history of Mirai Intex, refrigerants phaseout, future refrigerant options for ULT refrigeration, Aerocycle Technology, and much more. First, let's talk briefly about Mirai Intex history. Mirai Intex was established as an engineering company in 2015 in Switzerland. But what does Mirai and Intex actually mean? Mirai stands for future in Japanese, and Intex is an abbreviation created by combining two words, innovative and technologies. It was later decided that relocation to Central Europe with proximity to large airport would be beneficial. Vienna in Austria and Brno in Czech Republic were selected due to the convenience of Vienna International Airport and relatively short distance between these cities. In addition to production in Brno facility, this site also offers showroom where you can witness Mirai machines in operation. We offer training program for customers and distributors focused on the installation and maintenance of our refrigeration machines. Development process and manufacturing of the key Mirai machine components takes place in-house. Let's have a look on refrigerant phaseout with focus on ultra-low temperature refrigeration and what this means for applications below -40 degrees Celsius. There are multiple ways how to approach the F-gas regulation topic. Let me present just few simplified examples. First example is emission must be lowered by 73% from the 1990s levels. Second example is 2030 emissions must be lowered by 2/3 from the 2014 levels. In 2018, the first reduction step of 37% of the CO2 equivalent became valid, meaning that refrigerants with CO2 equivalent 63% of 2014 levels could be sold. Beginning of 2020 brought another challenge: ban of refrigerants with GWP greater than 2,500 with ban to service or maintain refrigeration equipment with charge size larger than 40 tons of CO2 equivalent. There are many more examples how to describe the F-gas regulation topic. More historic or current comparison can give a rough idea about the emission levels and decreasing of these levels. But what does it really mean in the practical, daily life way? There are two main outcomes. One is ban of refrigerants. There are refrigerants that are no longer available. Substitutes for phased-out refrigerants are not always one-to-one replacement. And the second is price increase of still available refrigerants. There has been a price increase in hundreds of percent for some refrigerants, which of course brought effect of questioning the sustainability of some installations going into the future. And not to forget about the uprise of the black market and the gray market where banned refrigerants are still available. There is an exception for ULT applications. But is this exception really a victory for the ultra-low temperature applications? It is not forbidden to use high GWP refrigerants in these applications, but availability of these refrigerants is rather questionable and you still have to pay a ridiculous price. And also, when this exception ceases to exist. Let's have a brief look on the refrigerants phase-out. Chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs, were successfully replaced by hydrofluorocarbons, HCFCs, and fluorocarbons, PFCs, some time ago. This solved high ozone depletion potential issue, but not a high global warming potential issue we are facing more recently. Hydrofluoroolefins, HFOs, and natural refrigerants are considered as the replacement for HFCs and PFCs. Please bear in mind that this summary is very generalized. Now, let's switch gears to the ultra-low temperature refrigerants. HFOs are direct replacement for medium and low temp applications, therefore not suitable for ultra-low temperatures. And even so, HFOs still come with their own challenges, such as lubrication issues, reactions with some metals, and other. There is not sufficient replacement portfolio built for ULT applications yet, hence the exception we touched briefly before. And who knows, there might never be equal replacements to high GWP refrigerants used in applications below -40 degrees Celsius. That is the reason why many see the future in the natural refrigerants. Basic example of two ULT refrigerants would be R14 and R23. To my knowledge, there is no direct replacement for R14. R23 can be replaced by WT69 with the designated number R469A. You can see on the slide that WT69 reduced global warming potential of R23 by 90%, but still has GWP much higher than any natural refrigerant suitable for ULT applications. Side note, R469A is a mixture of R744, R32, and R125. What are natural refrigerants options for ultra-low temperatures? One of them is ethane and propylene working in cascade, but both are A3 classified refrigerants. That means higher flammability, which brings the burden of strict safety measures and potential risk. Other frequently used solution for ULT refrigeration is liquid nitrogen. Liquid nitrogen is great for cryogenic applications, but has questionable benefits when it comes to the ultra-low temperature applications. Let's have a look at some pros and cons. Pros. Liquid nitrogen requires lower power due to, for example, missing compressor. It has high cooling capacity for very low temperatures. And the machinery itself has small footprint, but this depends on the size of the liquid nitrogen tank. Cons. Higher running costs. Liquid nitrogen has very energy-demanding manufacturing procedures. It has to be transported to the site location on periodical basis. And not to forget, it is a cryogenic fluid which is not very kind to living things. All things considered, is liquid nitrogen ecological? In my opinion, it is not. Let's get back to Mirai and where we see the future of ULT refrigeration. It is with natural air as refrigerant. It is indeed natural refrigerant that comes with no ODP or GWP. Since air is all around us, there is nothing or nobody regulating air. Air will be forever free of charge. At least let's hope we don't have to pay to breathe in the future. In special cases, air can reach up to -160 degrees Celsius. Air has greater efficiency in the ULT range than other solutions used. And last but not least, air is more economical than liquid nitrogen when running costs are considered. With air as refrigerant, we need to cover some basics of the Aerocycle technology first. How does it work from the perspective of thermodynamics? Aerocycle for refrigeration is described as a reversed Brayton cycle, sometimes also reversed Joule cycle. Temperature entropy diagram is the ideal way how to start with the basic principle. You can see dotted line between 1 and 2s, which is ideal isoentropic compression, and also dotted line between 4 and 5s, which is ideal isoentropic expansion. For obvious reasons, we will follow the diagram with only real processes. Let's have a brief look at them, and we will have a little summary shortly. 1 to 2 is real compression. 2 to 3 is constant pressure heat rejection. 3 to 4 is constant pressure heat transfer. 4 to 5, real expansion. 5 to 6, constant pressure heat supply. And 6 to 1, constant pressure heat transfer. This is how the Aerocycle refrigeration machine produced by Mirai works in simplified schematic. We'll skip to next slide to combine this and previous slide together in order to combine the theory and reality together. It is just a repetition of already mentioned processes, but this time shown on the refrigeration machine schematic. Point 1 can be seen at the compressor inlet. Number 2 is at the compressor outlet, completing the real compression in the compressor. Constant pressure heat rejection between points 2 and 3 takes place in the cooler that can be either water or air-cooled. Constant pressure heat transfer between points 3 and 4 takes place in the recuperator. Point number 4 is at the expander inlet. Number 5 is at the expander outlet, completing the real expansion in the expander. Between points 5 and 6 is where the magic happens. This is the process where constant pressure heat supply happens. Air is either supplied directly to the cold chamber or intersects in additional heat exchanger. More about this in a second. Last process is happening again in the recuperator between points 6 and 1, and it is constant pressure heat transfer. We will focus now on the heart of our machines. Take a look at the Mirai Turbo module. This great piece of machinery is allowing the previously described cycle to happen. As you can see on the picture, it is a very compact part. It is possible because the compressor and expander are located on the same shaft with motor between. With this design, we can save up to 30% of energy consumption compared to vapor compression systems used in the same applications. And why is that? In layman terms, when the air goes through the expanding process, it helps the motor to save energy to power the compression process, because both expander and compressor are located on the same shaft, as I mentioned before. So in conclusion, we can say that the expander work saves the compressor work with such design. And finally, our products that have been mentioned multiple times. We call our refrigeration machines Mirai Cold. Mirai Cold is the most advanced and the smallest refrigeration equipment for ULT using the Aerocycle Technology available today. Our products are CE certified, work in the ULT and sub-ULT range, and offers cooling capacity up to 16 kilowatts as of today. Higher cooling capacity will come. There are two basic principles how Mirai Cold works, in open and closed cycle. I'll explain our nomenclature for open cycle machine first. MC stands for Mirai Cold. The number behind represents motor power consumption in kilowatts. O stands for open cycle. And the last letter represents means of system cooling, so either water or air. Mirai Cold open cycle delivers air directly to the chamber. This is where constant pressure heat supply happens. Air then returns back to the machine through our revolutionary device we call humidity extraction device. This device traps all humidity in the air and transports it out of the chamber in the form of ice. The second mentioned working principle is the closed cycle. I'll explain only the differences in the nomenclature for closed cycle machines. C stands for closed cycle. Letter after C stands for system cooling, which is only water for the closed cycle machines. And the last letter means that the machine is factory equipped with additional heat exchanger. That is the reason why we call our closed cycle machines T models. In conclusion, closed cycle principle can be described like this. Air does not leave the machine. It is circulating inside the machine, intersecting in the additional heat exchanger, where it cools down the secondary working fluid such as silicone oil or others. More information about both working principles in greater detail in the next webinar. We would like to share with you the reason why we are so proud of our refrigeration machines. Let's talk about Mirai Cold benefits. It uses air as a refrigerant. This is more or less a recap of already stated benefits, why we think the air is the refrigerant of the future. What I would like to point out here is that you don't need to refill or store the refrigerant in this case. Air is all around us. You never ever would have to order refrigerant when using Aerocycle. When the site is prepared for our machines, it will take only 45 minutes for closed cycle machine or 4 to 5 hours for open cycle machine to be up and running. Using air as a refrigerant provides maximum safety possible. There are no chemically active substances, mainly compared to systems using refrigerants category A to L and higher. There is no risk of fire or explosion. Also related to refrigerants category A to L and higher, or even CO2, there is no need for additional safety measures like sensors, emergency ventilation, and system regular inspections. With all that considered, Mirai Cold do not require separate machine room. One of key benefits not mentioned so far is the oil-less design. We were able to design our machines with no need for oil due to the air-bearing design. This means reduced operating cost because there is no oil service plan required, and also reduced initial cost since the oil management is not required at all. No need for oil level sensors, oil separators, and no potential oil circulation ratio issues. This all results in a much higher reliability. With all already mentioned and with something still to come, let's talk about reduced operating costs. Due to the design and careful component selection, long life cycle is achieved. Aerocycle machines are very easy to operate and service, and the standard service procedures for conventional technologies are not required, such as no leak checks, no refrigerant refills, and no oil service as well. Energy efficiency is very important to us. This is the reason for our turbo module design that reduced up to 30% energy consumption. It is all in one device, so you don't need any evaporators or fans anymore. And with that said, you probably know what it means. No more defrosts. No need to cover defrost heat gains or heat gains from ventilators. Also, air-cooled machines can be optimized for automatically controlled cooling of the machine to save energy. And as mentioned before, when running costs are considered, air is more economical than liquid nitrogen. Aerocycle machines have a great key benefit in the form of stable operation. There are no sudden energy peaks required by the system's demand for cold. So in conclusion, Mirai Cold is very gentle with the power grid and cooling water demand. Since there are no defrost procedures necessary, this also contributes greatly to the operating stability. Another important feature is the strong part load performance, thanks to the inverter-driven motor. The machine will consume only energy relevant to current condition, because the operation of the machine controls motor speed automatically to match cooling requirements. No vibration or noise. It is coming from the turbo module design itself, but better to say it out loud. The design forbids any kind of vibration when operating, so this comes with the benefit of low vibration, low noise refrigeration machine. There is no need for racks or fixing it to the floor, and once again, no need for separate machine room. Mirai Cold machines operate with temperature accuracy of 0.5 degrees Celsius, which is allowed by the inverter-driven motor. For the open cycle machines are relevant following benefits: uniform temperature field in the cold chamber, reduced dew point in the time thanks to the humidity extraction device. Therefore, for example, no frost on the stored samples. When you use air as refrigerant, you will comply with all international standards, comply with all international regulations. You will not be submitted to F-gas regulation. Your system will work with very low pressures. For smaller machines, it is up to 4 bar, and for larger machines, it is up to 8 bar, so no more than a road bike tire. The last benefit is the control system. Mirai Cold machines are equipped with easy-to-use 7-inch touchscreen. possibility of real-time monitoring and data archiving. Integration of top-level control system is no problem with available protocols Profinet, EtherCAT, Ethernet I, and PowerLink. There is also an option for remote monitoring with assistance from Mirai remotely to solve any possible issue. It also allows the machines to be remotely updated with the new versions of software. This is all for the introduction episode, and now I would like to share with you topics for upcoming webinars. There are no dates set, but current participants will be automatically included in the future invitations. There will be still possibility to register on Mirai Intex website. I hope you liked today's webinar, and I can promise you that the upcoming ones will be only better than the first one. If you did, we would also appreciate if you share information about Mirai webinars to anybody who would be interested in presented topics. Thank you very much for listening to our recorded webinar, and I hope we'll interact with each other on the upcoming webinar episodes.